Hi, everyone. This is Niladri, and welcome to the session 19 of Project Management Professional Training. So, session 19, we are going to talk about quality management. And in this, we are going to go through the content in the way of like what is quality, and then see the basic fundamentals of quality, from where this quality thoughts are coming from, and finally have a deep dive into the quality management process, and finally into the 7 tools. Now, quality as a topic is theoretical, and I will suggest that you do a read on that from whatever reference book you have got with you. It's good to read, but overall, from quality, most of the questions will be coming from either the 7 tools. Okay, there are like 7 specific tools on the quality control on which a couple of questions can come, and also a few questions can be there, the basic questions on the definition of quality. Okay. Apart from that, on a large scale, you need to have a solid understanding between the difference between quality assurance and quality control. If you get the fundamental difference done between QA and QC, then you will be able to get the total quality for the project management concept clear. Pretty simple subject, but it needs a little bit of time. All I can say is that have one complete read through on any of the books which you have got, and spend some time on the 7 tools, which again we are going to discuss here. But it's like difficult to remember, right? Because the 7 tools, probably you may not be using all the 7 tools in your daily work. So it's good to know all the tools, and good to also have a real life kind of a work on those tools, at least like let's say every 15 minutes you spend on one of the tools and find out what it actually does. So questions on the exam can be, they show you a tool and they try to find out not only what the tool is, but some questions can be there on the tool based on the data or the graph plotting done on the tool. Okay, so with this, let's come. The first thing is what we have done so far, right? We have covered a lot, I will say a lot. Uh, Probably we are almost 80% done in the PMP knowledge areas. So we have completed scope, schedule, cost. Let me go ahead and pick up a annotation here. Give me 1 second. All right, so we have done where is my annotation? Okay, here it is. We have done scope, we have done schedule, we have done cost, we have done resources, communications, risk, and stakeholders. We are left with procurement, we are left with quality, and we are left with integration. So we are going to complete the quality, and the order will be then we are going to step into the procurement, and finally we are going to see all the mix and matches of the entire knowledge areas into integration. And once we are done with integration, then I will take you through the PMP syllabus again, just to go through that. Because PMP syllabus, if you start it like I will go through the syllabus point 1, 2, 3, 4 like that, you may be confused. The PMP exam content, the way they have written the blueprint, they basically start from the conflict first, and then they get into, I mean, they're focusing mainly on the areas or the groups like people process, right? So people process, they are kind of not having that order which we generally follow. So it's always good to learn PMP in the order which we are following here. It gives you a very, very nice way of understanding the concept. But once you're done with that, then it's very simple. You go to the PMP blueprint, and we can take you through like one by one. Okay, we have done this, and it's easy, right? All right, so let me remove this. Give me 1 sec. Clear drawings, and I think I'm done. Okay. So starting with, what is quality? Now, quality, if you look into the definition, a very simple one: degree to which the project fulfills requirements. It may sound very simple, but let me give you some examples to ensure we are getting a better understanding of what exactly is quality. So quality is something that whatever was there in the requirement capture, let's say in the waterfall project, whatever was captured from the customer in the requirements documentation, okay, and you got a sign off from that, exactly, if you're delivering the same to the customer, then that is called you have met the quality of the project. So in this case, let's say that you are, let's say, a real estate builder, right? And you are planning out to give a or give out a 10-story like building to your client, right? And the client says that once you are done, you paint the exterior of the building with, let's say, a very uncommon color. Let's say violet, and you paint that. Maybe it doesn't look good, right? But you paint it because the customer exactly wanted that. And does the project meet the requirements of the quality? Yes, of course. So quality is not about aesthetics. Quality is more about what the customer wanted. Now, there can be a problem with quality, especially in a waterfall model where your requirements are not captured. Especially in CIB, let's say, uh, in one of the lab requirement capture, you forgot to get the pointers for the geo WAPs, right, or the geo APs. And if that has not been captured, then once you deliver the program, like the day one or the day two, and then you're done with the labs, you still will be having that one thing not addressed, and the quality is not met. So especially in a waterfall kind of a project, always ensure that when you are capturing the requirements of the project or the program, you must be having them very much captured to the detail till the last dot, and it's signed off by the customer. Okay, so quality has got nothing to do with the aesthetics or the looks or the essence of it. It's more about what was there in the requirement document and what actually you delivered. That's quality. Quality should not be mixed with grading as well. Now, grading is a different concept. Grading means that again, let's say the same problem. Let's say you have got a real estate 10-floor building to be given to customer, and the customer wanted just one coating of painting done exterior, that violet color, right? Now, one coating of painting, some people will say, that's very poor grading of painting. You should be having at least three paintings, like three coatings to be done when you're talking about exteriors, to prevent the rust and the corrosion and all that stuff. Uh, they are right, but in this case, is it a quality problem of the project? No, because the customer asked exactly one coating and you gave. So some companies, they are also acting as a consultant to the customer. Maybe the customer was sharing the requirement, and probably if you are also acting as the consultant, you can share a little bit more, that what, I think one painting is fine, but three will be better looking at the long term life of the building. So if the customer says yes, then you put a yes to that. If the customer sticks to that, no, I will go with one coating of painting, fine, that's as per the requirement capture. So you are going to do something which is as per the requirements from the customer, and that's exactly what quality is. So quality has got nothing to do with grading and nothing to do with any aesthetic value. um, the other part of the quality is that uh, you know uh, in the whole, like when you are looking into the quality of the program, understand the impact as well. This is very important, because quality is not just something you met the requirements of the customer and gave it. Okay, sometimes you have to go a little bit deeper and find out what if this is not done and what can be the impact. The uh, good examples of impact can be, let's say in the manufacturing, you will be seeing that cars are being rolled out, right? And I think 2020 and 2019, somewhere in India, we had like one of the car manufacturers, I remember Hyundai, they did a rollback of their cars because the problem was with the software, where the airbags were not coming up in the right time, right? And say so they sent a message or email to all the customers to contact their dealers and to come a day for probably 10 minutes to get the softwares upgrade in the car. Okay, they tried to do it in a very, very nice way. Okay, I mean, to make it very pleasant and to have that cushion effect and all that. But still, people had to flock into the dealer's back and get this thing done, right? It was not a very pleasant experience for the customers. Okay, but that was still, I will say, a lesser impact. Okay, but again, if you look a little bit higher, you will see couple of years back we had this Boeing planes, three of them like crashed, right? Now they had this issue of the autopilot and the taking off and the software problem there. So these planes, they lost the control and they crashed, and finally end of the day the issue was so big that it was a kind of a finger pointing to the brand image of the company. So quality can lead to a disaster. It can take lives. It can lead to tarnish the brand image of the company. It can also even bankrupt the company. I will tell you again one more instance. We had a company in India based out of Bangalore called Redbus, in which people actually use their credit cards to book bus tickets online. And this particular platform had a glitch into that. So if you type in your credit card number incorrect even more than 3 times, then also it allows you to type in infinite times. So it will not stop you from punching in credit card number again and again and again and again. So that basically leads a very easy path for a hacker who can try out multiple permutation and combination to use or do harm to somebody's credit card, right? So that kind of things have gone to picture. They fixed it. So what I'm trying to say is that to a developer, maybe it's a very simple problem. Maybe a one line of code could have solved it, right? But to the end user, the impact might be very high. Somebody would have lost a lot of money. Somebody would have lost their life as well. When I'm talking about car manufacturers and aeroplane manufacturers. So quality is a very big thing. Do not ever misunderstand, like, I am only going to play with scope, time, cost, and stakeholder and risk, and I'm done with PMP. Quality is a very crucial topic, and the inputs of the quality is definitely your project charter as well. From the charter, you get to know what is about the project, the high risk and all, and from there you get slowly delve into the quality, and the quality complete the dump or the complete planning is done in the planning stage, where you get a complete quality management plan. So that's all about quality and a high level. So let's get into quality fundamentals. So there are certain pillars on which quality stands. Quality is not just a fluke of the concept which came on the table. Quality has been there for quite some time, and it has evolved over time, slowly but nicely. So one of the pillars of quality is that it's prevention over inspection, which means that we are more keen to prevent a quality issue rather than we go with some process with some unknowns and we find out some bugs and gaps at the end, and then we are trying to do an inspection, finding fault, and trying to do and trying to do the QC and close the bugs. Okay, see, QC is actually a part of QA. I'm sorry, I'm trying to give the terms like too early, but QA is quality assurance and QC is quality control. So quality assurance is the big guy. Okay, and inside QA, you will find QC as a subnet, okay, or as a subset rather. So uh, in the QA, what we do, we have got the quality planning done, the processes and the procedures, okay? And QC is something which you are going to implement into your monitor and control stage, where you are going to do an inspection over the variance and you find out. But that's not a good way, right? Because if our planning is solid and rigid, we may not have, or we may not find too many variants at the end of the game, right? It's very similar to a day one project. You're launching a site, right? You already have got all these standards in place. Your configurations are in place. um, your all the things are lined up to get the exact thing which you want as the output. I mean, your hardware models as per the standards, the entire like network configuration of all the devices, your switches, routers, firewalls, all are in place, the wireless and all. And then finally, when you have done the deployment, then you're running the UAT. When you run the UAT, definitely you will find a little bit of variance, but do we find it too much, like loads and loads of wireless AP is not working, or probably loads and loads of AV rooms have gone down, or telephony is not coming up? You may not find it, right? Most of the things will be working, and then after that, people will correct a few of them, maybe just a reboot or restart, and things will start working. Okay, maybe a sticky IP here and there. Okay, however, the point is that QC will always be done, but the aim is that prevention over inspection, that concept will build a very, very strong quality throughout the project, right? Second one, the important one, and on this you may find a question on the exam, that is about gold plating. So throughout the project cycle, the PM ensures to avoid gold plating. What exactly is gold plating? Gold plating is something where we say that if you are trying to give something extra to the customer, which he or she has not asked, some extra feature, some extra functionality, some extra scope, right? You want to make the customer happy. Okay, be very cautious on this. Sometimes, we, in the excitement of getting into the bracket of customer obsession. We are doing things probably which are not needed by the customer, and your effort is kind of going into vain. You could have used that work cycle to do something in a productive for the project. So let us say in this case, the customer has clearly told you that I want one coating of paint on the exterior of the building, right? But still, as your company wants to give a little bit more value to the customer, you are offering something. Okay, we are going to give you 3 coats of painting. Okay, that not only will lead to a sunken cost, that not only will lead to a zero ROI or a return of investment, but it adds no value to the project. Sometimes the customer may not even like that you're adding more features into the program or project. Okay, so always be careful. We are not here to do something extra scope, extra features, extra kind of functionality are a strict no in any kind of program. Okay, so no gold plating, and gold plating will go to further quality kind of issues. So if you are putting a gold plating into the project, then that will be the expectancy for the next cycle, and you are not going to have a quality standard for that, or your QC will not catch the gold plating. Okay, third one is about continuous improvement. Now, this is something which has been developed, slowly and incrementally year on year. So this is mostly a concept from Agile, but still in the waterfall as well, you will see the concepts like Kaizen or Six Sigma or total quality management, TQM. These are the things which will lead to that. Okay, first quality, this one looks nice. Let's say for a CIB day one project or program, you're doing it nicely. You got the essence of the quality. Okay, but then as the days improve, you might want to switch from UAT manual to a automated UAT, right? Or you might to do something in a better way as per the lessons learned in the past programs or the projects, right? So that continuous improvement of the quality is also something which the PM has to drive in the pro in I mean drive in the program. It can be a lessons learned, but as and when you are doing your first program and your 10th program or your 50th program, you must increase the layer or the level of the quality in the programs. And that has to be achieved slowly, not like one drastic change. Uh, you can take help of the user feedbacks. So basically for the AV rooms, right? We take a lot of feedbacks, like things are working fine or not, how is the sound quality, and so on and so forth, right? And based on that, you can make some changes like here and there. Okay, or next time we are going to do this, or we can do one more testing here as well. Okay. Similarly for Wi-Fi APs, okay, let's see that we have done this, but we can do a little bit more testing, or we can check out the density of the Wi-Fi APs more by probably playing a video in 2-3 locations on the floor at the same time and check it out how it works. And definitely we can use the automation ways also to check if the APs are all up and running in active state. So continuous improvement also brings in a lot of value to the quality fundamental. And finally, who is responsible or accountable for the quality of the product of the project? It's always the project manager. Okay, so if there is a quality problem in the project, it's not going to go to your senior manager or somebody else in the company. It will come to you, who is the project manager for the program. Um, so always make sure that you have got pretty good set standards quality in the program, which are called the quality assurance. Sometimes we do have got the quality plans in place, but we just don't know that these are called quality assurance. You already will be having a solid QA in the place, you just don't know it's a QA, right? And then once your QA is done, and then you also have to put a very solid QC in place. And you're also having an issue tracker where you're capturing all the issues. And your aim should be that maybe your first 5 projects had got let's say 20 issues per project, right? You have to bring it down. It will never come down to zero, right? You cannot make it really zero. That's the ideal world. But you have to bring it down to the as least number as possible. Okay, and everything should be known. There should not be any kind of unknown or surprises, which has been found by the end user and not known by you. Okay, anything which is found by you, which is known by you, which is kind of a very deep-rooted kind of a problem which is there in the hardware maybe or in the software, you should be telling the end user then and there. This is what, if you do X plus Wi-Fi Z, then probably you will see this kind of thing coming up. Okay, so That's about it. So these are the fundamentals of quality. So quality is not just like, somebody wrote a quality doc and it became a standard of project management. It's more like slowly over the years and decades, things started slowly seeping in. Especially when I talk about continuous improvement, that has came from the concept of like, Japan, who led the concepts of lean after the Second World War, and after that they got like Toyota as the company. They had the first lean concept in them, and from there slowly you got this Kaizen and all these other nice concepts. Six Sigma was also somewhere closer to that time period where they made it a very high strict standard and how to improve quality over time. So all these were built in slowly into projects, and most of them are actually widely used in software like product projects. But but they can be equally used for any IT infra projects as well. Okay, now let's talk about quality management process. So when I talk about the quality management process, that is basically the overview about the three stages of quality that you have got. And here we're going to break out the quality into two parts. One is QA and one is QC. The three layers of the quality management throughout your project lifecycle will be: you plan the quality management, which we do, of course, in the planning stage. The second one is the managing the quality, which is being done in the execution stage. And the third one is the controlling the quality, which is done in the monitor and control stage. So during the plan quality management, which we do in the planning stage, this is basically where you are getting into what is what. Like you define the quality for the project and you plan how that will be achieved. So you draw the quality plan for the project. You probably have separate a plan where it says that you need to have some separate quality checks done from the beginning. These are ensured will be done as per they are. You also can have some separate quality checkers in the team. In a software life cycle, you will be having some software like testers in the beginning of the game who will start the dynamic testing once the coding is going on. So like that, you will have a plan in front of you, right? In the execution stage, when you're executing the plan, then you will be actually checking that how the work is being done as per the plan, right? And here also the PM will ensure that they are getting the inputs nicely, like uh, talking about things in the future, like do we need to improve the quality plans for the future projects? So you may find out during the execution stage that maybe a certain piece of the coding is not like supposed to be deployed in that fashion, right? And then you find out, okay, if this is the case, then for next projects we are uh, not going to go in this way, but we are going to improve it by having a change in the quality plan. Something like, let's say nowadays we do not go to change the configurations in the manually, right? We have to go through the BRWF workflows. um, that is also a way to ensure that we do not have a human error, or everything is kind of going through a workflow which is more automated, and having the chances of the defects are pretty much less there. So that's about the managing the quality in the execution stage. And when it comes to the monitoring and the controlling stage, that's where you have the QC or the quality control in picture, where we are taking into account like measuring the variance. Okay, so we checked that, okay, this is the finished product and this is what the customer wanted. And do we have got any variations to that, to what the customer wanted? If there is, then what it is and what is the gap and how we need to fix it. That is basically the inspection over prevention. So this is the inspection method, and inspection has to be done for any project, for any program. You have to have a inspection a way to do it. In our case, in CIBs and day ones, we have got a UAT in place, and UAT will be telling you that, okay, out of maybe 150 Wi-Fi APs, 140 are up and 10 are down, and you have to find out why they're down, right? Maybe they're not provisioned correctly, or there is something else going on with the cabling, and so on and so forth. So inspection is the last stage where you check out, like, okay, fine, how have we done? And the less you have got the defects in the very last stage, that means that you have really done well. You have actually included quality from the beginning. See, certain things in the program or the project you cannot include in the mid of the project. And what they are: number one is quality, and number two is security. If you're talking to, let's say, a product person who is developing a product, let's say a hardcore, like a product, let's say Nexus, series of switches, right? They will include that security right from the beginning. The security is one of the concepts from the beginning to be taken into consideration. And I'm not just talking about the security in terms of the control plane and the data plane. I'm talking about the security in terms of the hardware device and the chassis as well. Okay, the locking mechanisms. So uh, security and also the quality, they cannot be mitigated in middle of the game. You have to take them into the consideration from the beginning. If you are going to serve to a client in a waterfall method, you have to ensure your requirement doc is having the details till the last dot, and you are getting a sign off from the customer on that. And if it's a product which you are manufacturing, and that is to be catered to a large end user, then you have to develop your own quality plans, your own requirement capturing what the customer wants and what can be given. And you have to look from all the corners, like how this can or cannot have an impact to the end user in a large scale. You just cannot think about from the developer standpoint or from the tester standpoint or from the design standpoint, right? Because you cannot change the design in the middle of the game, right? But if that is to be done, if you are going to change the design in the middle of the game, a lot of sunk cost will be there, and a lot of time will be wasted. I will say a lot of wasted cycles will be happening, and end of the day, your product will not launch in the time in which we're supposed to be launching it. So quality has to be there from the beginning, to have the quality plan, and then to manage it, to find out how do we improve it cycle after cycle, and finally we control the quality, right? Through various ways and means that we have got. So that's the basis of the quality which we have got for PMP. Questions on the exam will be on this topic, mostly the 7 tools of quality management, or we call the 7 tools in QC. Um, the questions can be super simple to little bit tough as well. I will not say super tough questions will come on this area, but little tough questions in the sense that the PMI will try to check, do you really know these tools? So they will actually give you a graph with some numbers and ask you that, what does the graph indicate? Is it within the variance limits, or the deliverables are correct, and all that stuff? Because they will ask you some simple questions, but you have to have a good understanding of the tools to make the correct choice in the exam. So the 7 tools of the quality control are cause and effect diagram, followed by control chart, flow charting, histogram, Pareto chart, run chart, and scatter diagrams. Out of all the 7, probably all of you will be knowing, let's say, flow charting and histogram. These two are well known. Remaining, you may have used or may not have used. And that's why I say always that uh, go through this 7 tools one by one. We are going to take a quick go through of each one of them, but that's not enough. Spend some more time on them. At least try to solve 1 or 2 like questions with them, and then you will be well versed with the tool. So these tools should be like pretty easy to crack in the exam, the questions, like I said, but if you don't know the tool, you will not be able to answer the question. Or if you know the tool from a very high level, then also probably will not get the correct answer. So the first one is cause and effect diagram. That's called the fishbone or the Ishikawa. The cause and effect diagram, always remember that is to find out the root cause analysis. Now, this diagram, like you see, it's like a fishbone kind of a structure. That's why I call it fishbone. And there are 2 ends to it. Let me pick up an annotation here quickly. So there are like, uh, where is my, okay. There are like 2, fish bones here. Now, you can do it like this, the possible cause, and some people, they do it like possible cause and effect. So what you can do is that the causes and their effect can be placed in a visual way. Like one possible cause can be like, if I am, let's say you work in a call center, okay, and let's say the cab comes to pick you up from your home at uh, uh, you know uh, let's say 8 in the morning, for you to reach office at 9, right? Now, if you are delayed by traffic, let's say one day you're delayed by 5 minutes, or everybody gets delayed by 5 minutes to reach the call center, which means that a complete batch of 100 people are not logging in on time on a call center. What is the impact to the business? So you can have this chart to tell you that 5 minutes of delay will lead to maybe $500,000 of business loss. Okay, if it's a critical business kind of a thing, and then 10 minutes of delay will lead to this much amount of money, and how do you solve it and all that stuff. So the root cause analysis can also be found out. The impact can also be depicted well, visually from this kind of diagrams. Okay, that's about this Ishikawa diagram. The second one is control charts. The control chart is about where we are seeing the established control limits. So what we do here is that, let me quickly pick up this. Yeah, we have got a graph here where we plot it, right? And on the top of the graph, we have got the UCL, we call it the upper control limit, and the bottom we have got the lower control limit, or the LCL. In between, we have got a median kind of a green line, right? The center line, which we say. So we are telling that if the variance is falling between the upper and the lower control, or almost close to the median, it's good. But there can be some outliers. Like in this case, let's see, this dot is going a little bit very close to the upper control limit. So as many of outliers you have got, that shows you the trend that, hey, we are not in a good position. Or maybe out of 10 dots, you are having probably one outlier. You have to check if that is acceptable or not. Okay, so that kind of analysis and showing a trend of the plotted values between the control limits. Okay, so that's about your control charts. We have got the flow charting, which is very simple. Like I said, most of us know what flow charting is. It's all about you are going to depict your project activities or works in a visual way. And also you show that how the tasks in your projects are kind of interrelated or kind of connected. Histogram is also something which we all know. It's a bar chart, basically. A bar chart which is showing the distribution of the variables over time. And this is like simply a very plain and simple bar chart, which we keep on like using. So histogram and flowcharts are the common ones. The uncommon ones are maybe the fishbone diagram and also the control chart. You might be getting some questions on the control chart, because that's where I've seen most of the trend of the questions are. Pareto chart is something where you are seeing the frequency of the occurrence, like how many of the results were generated by each of the identified in the variance. So let's say in this case on the bottom, you will be seeing, okay, you will be seeing this, multiple stuff, right? The installation, uh, software fault, the shipping, and blah, 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 right? Now, looking at this chart, you can quickly find out which are the top three in the list which are creating all my trouble. Okay, or the variance, and you will say, okay, we have got like 1, 2, 3, 4, 5, 6, like 7 of them, but these top three, especially the first three, the installation and the fault and the shipping, these three, if you can solve the problem, then probably your variances or the numbers will really go down, right? So this chart is more about not just the trends, but to look into what are the top impactful items in one shot. Okay, and then we have got the run chart. Run chart is more or less like when you are plotting a graph over like a data over time, and it is just to show the trends in the variation of the process. Number of bugs getting fixed month on month, number of issues getting open or closed month on month, and so on. It's a simple one. Now, like fundamentally, you will see that there is a confusion, right? When you look into run chart and Pareto chart, I know that they are not same. But since you may not have used them on your daily work, you may have the confusion of this in the exam. So be completely, what do you say, used to them, practice them. Run charts and the Pareto charts are very simple, but you may get 1 or 2 questions in the exam. But questions can be more, like I said, on the control charts. And lastly, scatter diagram. Again, very simple, where you are trying to show a kind of a quantitative analysis on the mathematical, statistics of two variables. So let's say you're saying that the new test cases versus the defects, and you're saying the defects being generated, and you get a random kind of a two-way effective way of calculation by checking with the variables of two. Okay. Scatter diagrams, I probably have not found any question seen yet, or it's more like one of the rare areas. But definitely the questions come more on the areas of fishbone and control chart, and you may also get some easy questions on, let's say, a histogram or flow chart if you're lucky. But at least know that what each of these charts do. Okay, a simple question can be scatter diagrams is for 4 variables, which is Incorrect. It's only for 2. So like that kind of easy questions can be there, but I will say spend time on them, at least 15 minutes per chart, and be used to them. Okay, so that's about most of the parts of this. Let me quickly remove this. 1 second. Okay, so let's wrap up. First one is the prevention over inspection. Like I said, is the fundamental thought in the project quality. That's the basic thought. I mean, if you always try to do quality control, then you are not doing a good project quality over the project life cycle. You have to have a good prevention, which is called a QA process, to ensure that yes, your project is having some standard quality processes inbuilt. Gold plating is a strict no-no. Okay, when you're looking for the continuous improvement, know these terms and also know what they are. Most of them are like Japanese, Kaizen, Six Sigma, or TQM, which is called the total quality management. These are the things which are the areas, or which are the tools which we use to continuously improve the quality in the project. And finally, which I said, the area where you might get most of the questions in the exam, that is about 7 tools which are being used in the project quality management. All right, with that, we came to the end of the session. I hope you all liked it. Thank you for watching it. Hope you have a great day and a great time. Thank you.